right, so this video is going to kind of move on from our notes from where we left off, which was right here at example problem number 1. So it was the density of a 15-gram box, and since this was a solid object, we could assume that we can use length times width times height as our volume to get that. But other times you might have a cylinder or anything like that you might have to find the volume of, so just be aware of that. Now we're also going to talk about using volume to calculate density when it comes to liquids. Now before we write anything over here, what I would like you guys to write down first is some important information. This is going to go on the opposite side, or that in that margin area. So don't put this down underneath this here. I want this to go in the margin of your paper. I just want us to write down the density of water. So water has a known density of about 1.0 grams per milliliter. And if any object greater than, objects that have a density greater than 1.0 will sink, and likewise objects with a density less than 1.0 will float on water. This is an important distinction, and this actually applies to anything of any liquids of all densities, or solid objects or liquid objects of all densities, that depending on the density of the liquid, that if it has a density that's more than that of the liquid, it will sink. If it has a density that's less than that of the liquid, it will float. So this, like I said, the 1.0 doesn't necessarily just apply to this. So pause the video here if you need to continue writing that. Otherwise, I'm going to erase that so we can pull up the notes for this part. All right, so we found the volume of a solid object. For the second one here, we're going to find the volume of a liquid object, but we are going to use a graduated cylinder method. So this is what we're going to use if we want to find the volume of a liquid, or we can also use this if we want to find the volume of an irregular shaped solid. Irregular shape meaning I can't use length, width, and height to measure it, like a rock. So this is called the water displacement method, but we're going to be using a graduated cylinder either to measure the volume of a liquid or a regular shaped object. It is measured in milliliters, so we'll use those units, but we'll switch them in the case of when we have a solid object. So the water displacement method we have actually already done in class, but here are the steps to that as a reminder. So please write these down. I know that we have talked about it, but I would want you to write them down. So you first have to put enough water in your graduated cylinder to cover the object. And if you need to obviously make sure that the water goes up and over the object. So if you have a kind of a longer skinny one, set it to the side or kind of stand it up to the side of the graduated cylinder so you know how much you at least need to put in there. So you got to put enough in there to cover it. You don't have to get to any certain volume. You just record down your initial volume. I'm somebody though that kind of likes to start at like a known volume, like something in the tens place. It's just easy to see and get to, but you don't have to do that. That kind of takes practice to get to exactly what you need to there. So any volume is fine, but you need to record down your initial volume. Then you go ahead and you add your object, and I usually recommend kind of tilting your graduated cylinder so it kind of slides in, so you don't create any water kind of jumping out of there or splashing out of there. Then you're going to take a look at the new volume, the final volume, with your object in it. So we need to make sure that we understand what those words initial and final mean when we're talking about volume, because we have an equation here that we're going to use to find that. So it'll be this equation down here. So VF minus VI. So you're going to subtract that to find the volume of the object. So if you need more time, go ahead and pause the video here to finish writing this. Otherwise, I'm going to move on to example number 2. Example number 2 here says a sample of aluminum is put into 10.5 milliliters of water, and then if the water rises to 13.5 milliliters when the aluminum is added, what is the density if this sample has a mass of 8.1? So I'm trying to find density. That's my unknown. My mass is given to me. It's 8.1. My volume right now is unknown. It's not given to me. It's not 10.5 and it's not 13.5. Sometimes students are quick to just look at the numbers in the problem and use them. This one's telling me that the water displacement method was used. And so I'm going to have to use the equation VF minus VI in order to find that. So VF minus VI is 13.5 minus 10.5. So as far as the work, like what do I want to see from you? At bare minimum, I want to see this. I want to see if you have to calculate the volume, I want you to be using this equation up here, your volume of your final minus your initial. So you're going to go ahead and write those numbers there and then solve for it. So that ends up being in milliliters here. That's just how much the water level went up. But we know that we can because this is aluminum is a solid object, I'm going to actually transfer the volume from milliliters to centimeters cubed. And that's what I want my final volume in my density to be in, because milliliters and centimeters cubed can be swapped in and out. So my density is going to equal 8.1 divided by 3. Now, we're making sure we put our units in here, so that's 8.1 grams. And then the 3 here now becomes, and if you wanted to kind of write it over here, just so we understand why we're doing this, 3 milliliters is the same thing as 3 centimeters cubed. And I want to use 3 centimeters cubed because this is a solid object. So I'm asking about the density of aluminum. Again, I prefer it to be in centimeters cubed. So then when we go ahead and solve for this, we end up with 2.7. Again, I'm crossing that out there. I would prefer that to be in centimeters cubed since it is a solid object. So you really have to look at what are you measuring as far as density goes. All right, so we are going to do some of the practice when we come back in person. So for now, I'm going to move on to our next part of the notes, which is going to be on chemical properties. So chemical properties are different than physical properties. Remember, physical properties, you don't change the substance. You can, measure these without any sort of reaction or anything like that. Chemical properties here are properties that you can only observe when the chemical or the what you're starting with ends up being changed. The identity gets changed, the formula gets changed, so something changes within that that object, that substance, that mineral, that element. So usually you know that you have some sort of chemical property if a new substance is formed afterwards that wasn't there before. Sometimes it's hard to know exactly like when a new substance might have been formed, but we'll go over lots of examples so you should be able to tell. So here's some properties that are considered chemical properties. If an object or a chemical is toxic, so how toxic is it? If it's flammable, and how flammable is it? Combustibility, radioactivity, all of these are examples of chemical properties. And then we're also going to go into several examples of other ones too that we'll discuss in more detail. But all of these are examples of some of the chemical properties that a lot of different substances have. So again, pause the video if you need to create. But one of the keywords here is if a new substance is formed. So looking at these pictures over here, we can see burning and we can see rusting. Those are two examples of some of the chemical properties that we'll talk about here. So combustibility we mentioned already. This is basically how easily a substance can set on fire. So a lot of substances have a combustibility rating. Example here, if you want to write the example, you can. I do suggest writing it. I know it's in italicized, but I don't think it'll hurt you to write it. So burning charcoal could be an example here. Reactivity has a lot to do with anytime you see that word react, blank reacts with blank, or these two things are put together and a reaction occurs. Anytime you see that word react, you know that it's some type of chemical property. Reactivity indicates that a chemical change has taken place. Sometimes we'll talk about how easily a substance reacts, sometimes with an acid or a base. And usually those are going to indicate some sort of reaction. Again, you don't have to write this as an example, but fluorine gas fluorine is one of our elements on the periodic table. Fluorine gas is highly reactive and will spontaneously ignite even just a concrete block at room temperature. So fluorine gas is one of those that are you just don't see really used at all for anything. And then oxidation is like that picture that's there of the rusty old car. So these are how easily a substance reacts with oxygen. And usually it's iron. A lot of times it's iron or steel, which contains iron in it. But that's reacting with oxygen. And then usually moisture to create rust. So a lot of times there has to be maybe some sort of moisture involved in order to create rust, or at least to speed up the rust or oxidation making process. So I would recommend maybe writing down that example there. Now we combine both of these together, chemical properties and physical properties. Now we'll talk about physical and chemical changes. You don't have to write this, but matter can undergo both physical and chemical changes, and it's important to be able to decide if that change is physical or chemical. So a physical change is not the same thing as a physical property, but it's kind of similar because it's involved. So a physical change is a change in a substance that only affects its physical properties. So a change in mass, a change in size, a change in melting temperature, any of those. If you melt something, if you heat something, most of the time you're only applying physical changes to that. You haven't actually created any new substance. All right, I do maybe recommend writing down these if that helps you remember some of the physical changes. So anytime you see these words, cutting, coloring, crushing, melting, boiling, those are all just going to be physical changes that you would see. And then a chemical change is what happens when a substance undergoes some sort of chemical reaction that results in something new, a new substance being created, but definitely a chemical reaction would have taken place. So what do you look for chemical changes, examples of that? Burning, rusting, decomposing. And then down here we define a chemical reaction, and a lot of chemistry is based off of this idea right here. So a chemical reaction is a process by which the atoms, we know what an atom is, atoms are elements, of one or more substances are rearranged to form different substances. So the atoms of one or more substances are rearranged to form different or new substances. So that is again a big indicator that you have some sort of chemical change. Chemical reactions indicate chemical change. We just have a couple to finish up here. So one of the last things that we'll talk about here is the law of conservation of matter. So this is a law, which means that in science terms, this is something that is applied and happens all the time here. It's like the law of gravity. All right, so it's deep-rooted in a lot of its variability. So the law of conservation of mass says this: matter is neither created nor destroyed during a chemical change, it only changes form. So as far as, I always kind of look at it like this: the number of atoms that you start with should be the number of atoms that you end with. All right, or the number of elements that you start with should be the number of elements that you end with. And so that goes to help explain this law of conservation of mass. So mass cannot be lost even when a chemical reaction happens. There are, examples in labs that we might either do or watch that kind of help explain this and show this actually, so you can realize that. So, sometimes what we'll do is we'll do an experiment like this where you can take a match, you can take the mass of it, and then you light it and you burn it and you take the mass after it. And if you can imagine, the mass of the match afterwards is less. It weighs less. Why is that? All right, where did the rest of the mass go? It got changed into a different form, like smoke. So the atoms that were making up the wood particle, of that matchstick are now in the air as smoke. So they've just changed forms, but you haven't lost any mass specifically, even though I know on a scale it might look like that. It's just changed forms, and unless you can find a way to capture the gas, you might think that it's been lost, but in actuality it hasn't. And then the last thing we'll talk about here is evidence of chemical changes. So these are signs that a chemical change has occurred. So this really helps us decide whether something is a physical or a chemical change. So look for things like this. Release of light. So any form of light that wasn't there before would be an example of that. Temperature change, either up or down. An odor change. All right. Now, odor is technically just a physical property. Like vinegar has an odor to it, but just because you use vinegar or anything doesn't mean that you're going to necessarily have to have a chemical reaction. But if there is an odor change, so all of a sudden there's a smell that wasn't there before, or a smell goes away, that would be an example of a chemical change. A sudden color change. Okay, so that's another example of a chemical change. If you have gases given off, either in a form that you can see like smoke, or gas bubbles, like when we did the Alka-Seltzer tablets, that was a gas that was getting released. And then sometimes we'll call the sudden appearance of a solid. When you mix two liquids together and you get a solid, this is known as a precipitate. So the sudden appearance of a solid when you mix two liquids together is known as a precipitate. Okay, so that is it for the notes for this part. So please have those done by your next class period.